Hey there, welcome back to our exciting journey. Today, we're diving into the world of creating a search engine for our web app. But before we kick things off, I've got a little gem for you. Check out this must-watch video to learn how to create and connect a PostgreSQL database to your local Django project. Once you've wrapped up with that video, we'll seamlessly continue by connecting that very database with Django. You'll find the link in the description below. Once you've obtained your password, database port, and all the necessary details to connect to the PostgreSQL database, we can now proceed to edit the settings file to incorporate this information into our database engine. Replace X with the password you used when you created the PostgreSQL user. Now, the new database is empty. Run the following command to apply all database migrations to the new PostgreSQL database. Now, navigate to the forms.py file of your blog application. This is where you'll define your search form. Inside Forms, create a new class named Search Form. This class will inherit from forms.form, which is a base class for creating forms in Django. Within the Search Form class, add a field called Query. This field will be used to capture the user search query. In this case, we're defining it as a Django form field for text input. It is the most common choice for capturing text-based data, like search queries. Now, edit the views.py file of the blog. And import both the search form and the search vector at the top of your file. Now, for improved organization and code readability, it's time to define a new view, specifically for rendering searched posts. While it's technically possible to add this functionality to an existing view, creating a dedicated view is a best practice. Scroll down in your file and let's create a new view, named Post Search. This way, we will maintain a clean and structured codebase. In the beginning, we create an instance of the search form class. This form will be used to capture the user search query. We initialize query variables to none and results as an empty list. These will be used to store the search query and the search results. we check if the query parameter is present in the GET request. This parameter will contain the user search query. If query is found in the GET parameters, we populate the search form with the data from the request. Then, we check if the form is valid. If the form is valid, we retrieve the clean data from the form, which contains the user search query. We use Django's search vector to search for the query in the title and body fields of posts. This line of code is a crucial part. Let's go through it step by step. The post.objects part of the code is the starting point. It represents the model for your post objects in the database. In Django, you interact with the database using models, which are Python classes that represent database tables. The annotate method is used to add additional information to the query results. In this case, it's adding a new field called search to each post object. This field is created using the search vector function. The search field will hold the results of the search operation. At this juncture, it would be advisable to delve into a detailed explanation of the annotate method, given its potential significance. In the context of our discussion, the annotate method in Django is a powerful tool for adding calculated fields to query sets. It allows you to perform complex operations on the data retrieved from your database and include the results in the query set. Let's walk through an example using a simple model, view, and an HTML template. We created a simple model for a blog with two fields, title and content. Now, we want to create a view that displays a list of blogs along with the word count for each blog post. Here, we import the f object and value from the Django.db.models module. F is used for database field references, and value is used to provide a constant value for database operations. We also import the length and replace functions from the Django.db.models.functions module. These functions are used to perform database operations on text fields, where length calculates the length of a string, and replace is used to replace occurrences of a substring in a string. We start by defining a view function named postList. It takes a request object as a parameter, which is automatically provided by Django for each incoming HTTP request. Now, we are querying the database using the blog model. In this line of code, we're using Django's annotate method to create a new field called word count for each blog post in the query set. This word count field will store the count of words in the content field of each blog post. Let's break down this line, step by step. This part specifies the model we want to query, which is the blog model. We're accessing the database table associated with the blog model. Annotate is a powerful method in Django's query set API. It's used for adding new fields to the query set. In this case, we're adding a field called word count. Word count is the name we give to the new field that will be added to each blog post in the query set. Length is a database function in Django. It calculates the length of a given string. Replace is another database function. It replaces all occurrences of a substring with another substring in a given string. Here's how it works. This part replaces all spaces in the content field with empty strings, so it effectively removes all spaces from the content. Then if we add the length method to this part, it will calculate the length of the modified content without spaces. Finally, we add 1 to account for the last word. This is because the count of spaces is 1 less than the count of words. So, the entire expression calculates the word count for the content field of each blog post. And this value is stored in the word count field for each post, thanks to the annotate method. Now, for the final touch, let's gently introduce our model to the admin panel and, naturally, pave the way to its presence on our site. Observe how we incorporate the word count in our template. It's important to recall that this field was generated within our views through the annotate method and was not initially defined in our models. Now, let's pick up right where we left off while crafting our search view. The filter part of the code filters the post objects. It restricts the results to only include objects where the search field matches the query you've obtained from the user. This is where the actual search is executed. This time, we're applying the same pagination logic. As in the previous views, this not only ensures consistency, but also helps us save valuable time, avoiding unnecessary repetition. If you've reached this point in the tutorial, I'm confident that you've got a good grasp of what we're doing. Many of the concepts covered here have been discussed in our previous sections. However, if you find yourself struggling to understand, I highly recommend revisiting the earlier video to build the necessary skill set. It's a great way to ensure a solid understanding of the material. Now, I'd like you to create a postsearch.html template. Inside the home directory, this is where we'll display the results of our searched query. To streamline the process, you can copy everything from the filters.html template. Since we're looping through a page object, just like we did in the filter views, paste everything into the postsearch.html template. Now, I'd like you to open the header.html template, which can be found in the Components folder. Within the templates, scroll down to locate the form. Once you've found it, update the name attribute to query and set the action attribute to the search URL, which is the name of our URL for the search functionality. Now, it's time to open your website in your browser. Refresh the page and try searching for any title you desire. When you hit enter, you'll notice that the default search template provided by the Wagtail app is the one being rendered. To change this, go ahead and delete the search app in all occurrences within our project. After that, refresh the browser once more. There you go. You've just successfully created an awesome search engine for your web app. Alright, now that you've got the hang of this, the beauty of Django goes far beyond just a basic search engine. There's a whole world of possibilities to explore when it comes to search engines in Django, and that's exactly what we're diving into. We're talking about things like stemming and ranking results. You heard it right, so buckle up, because there's a lot more to discover. Edit the views.py file of the blog application and add the following imports. Alright, we're going to start by spicing up our post search view. After that, I'll break down the nitty-gritty details of what's going on. Now, let's take a closer look and dive deeper into the key elements of this code. Here, we create a search vector object using the search vector function. This object is responsible for determining how well each post in our dataset matches the user's search query. We specify the fields we want to search in, which are title and body. In this case, the search vector will generate a vector of search terms based on the content of these fields. Next, we create a search query object using the search query function. This object represents the user's search query and helps us compare it with the content in the specified fields. We start building our final query set of search results. For the post model, we use the annotate method to add to new attributes, search and rank, to each post object in the query set. The search attribute is assigned the value of the search vector. This means that for each post in the query set, the search attribute will contain the search vector that represents how well that post matches the user's query in the specified fields. The rank attribute is calculated using the search rank function. It takes the search vector and the search query as arguments to assess the relevance of each post in relation to the user's search query. It assigns a score to each post based on how closely it matches the query. After annotating the post model instances with search and rank attributes, we filter the query set to only include posts that match the user's query. This is done by comparing the search attribute with the search_query. Finally, we order the filtered query set in descending order based on the rank attribute. This ensures that posts with higher relevance scores appear at the top of the search results. Now, open the admin and create some posts. Try repeating a specific word within those posts to test whether the search engine is functioning effectively. This will help you assess the ranking and relevance of search results. It seems like we've got a little typo error here. Time to give it a quick correction. Here, I'm performing a search for a post containing the word Django in either its title or body. The post with the highest ranking will proudly take its place at the top of the results. Check this out, it's the power of precision in action. To implement stemming and stop word removal in Django, we harness the flexibility provided by the search vector and search query. These classes can be configured to accommodate different languages seamlessly. This is achieved by specifying a config attribute, which allows us to select the appropriate search configuration. Here, we are configuring our search to execute stemming and remove stop words in English. We can boost specific vectors, so that more weight is attributed to them when ordering results by relevancy, for example. We can use this to give more relevance to posts that are matched by title rather than by content. In this code, we apply different weights to the search vectors built using the title and body fields. The default weights are D, C, B, and A, and they refer to the numbers 0.1, 0.2, 0.4, and 1.0, respectively. We apply a weight of 1 to the title search vector, and a weight of 0.4 to the body vector. Title matches will prevail over body content matches. We filter the results to display only the ones with a rank higher than 0.3.